Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at trigonometric equations of the form a sine x plus b cos x equals c. So this is one such equation. Now I'm going to give you two methods for solving this. The first method involves squaring. What we do here is we get the coses and sines to opposite sides of the equal sign. So here I'm just adding 5 sine x to both sides. And then as the name suggests, we square each side. We square this and we square this using FOIL. So we square the first, we square the second, so that's always positive. And then in the middle goes twice the product of the two terms. So 2 times -1 times 5 sine x. Now the problem here is that we've got coses and sines. We want to make it so we only have coses or only have sines. So I can rewrite this here because remember cos squared x is the same as 1 minus sine squared x. So now to make life easier on myself, I'm going to expand the brackets, but I'm going to let y equal sine x, and that'll allow me to have an easy quadratic to solve. So I get 3 minus 3y squared equals, now I'm going to replace sine squared x with y squared and sine x with y. So to solve a quadratic, we need one side equal to 0, so we add 3y squared to both sides, and we also subtract 3 from both sides. So to solve this, it's probably easiest to use the quadratic formula. So putting that into our calculator, we get y is equal to 1/2 or -1/7. But remember that y was equal to sine x. So we have either sine x equals 1/2, and in degrees, that tells us that x equals 30 or 150. The other possibility is that sine x equals -1/7, and you can just use your calculator, sine inverse of -1/7, and using the unit circle, our other solution is 359.71 degrees. Now when you're using this method, you have to check your solutions. It turns out this one and this one don't work. You check them by substituting into your original equation. The problem arose because the fact that we squared both sides. If a squared equals b squared, that doesn't imply that a equals b. We could have a equals -b. So when we're using the squaring method, you always need to check your answers. Now I'm going to solve this equation using another method. So the other method I'll show you involves a trick we saw in a previous lesson. We write this expression as r sine or cos of x plus or minus some angle alpha. It really doesn't matter whether you choose sine or cos for this. So whichever we choose, we get r is equal to the square root of 5 squared plus root 3 squared. R is equal to the square root of 28. So taking that out the front, we get root 28 of root 3 on root 28, and then we divide this by root 28 as well. So if I want this to be in the form sine of something, I need to take sine inverse of that. If I want it to be in the form cos of something, I'll take the cos inverse of that. So I'll just pick cos. It wouldn't have mattered if I picked sine. So cos inverse of that is about 70.893 degrees. So just note that if your solutions are in degrees, this needs to be in degrees. And if you're asked for solutions in radians, this needs to be in radians. So what we have now is this. So remember that for the cosine, for angle sum and difference, this sign is the opposite of the sign between the terms. So a minus here means there's a plus there. This was cos 70.893, and this is sine of 70.893. That's why I was able to transform it as such. So now it's quite easy to solve. First thing I do is divide each side by root 28. I now take the cos inverse of both sides. So I have 70.893. Now one of the solutions to cos inverse of -1 on root 28 is 100.893. So subtracting 70.893 from both sides, I just get x is 30 degrees. But there is another solution to cos of something is -1 on root 28. And that one will just be 360 minus that. So I also have x plus 70.893 is 259 point blah blah blah. Subtracting 70.893, I get x is approximately 188.21. Notice these are the same solutions I obtained using the first method. So this method doesn't have the problem whereby we have to check the solutions and make sure that they work. But really, either method you use is valid. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.